Hi, welcome. We are doing special right triangles today, which is 9.4, and it's page 26. This is a really big set of notes. You're going to have to know these, you have to memorize them, or you remember how to figure them out. But this is something that you're going to see again, and it's not going to go away. It's not going to go away in Algebra 2, pre-calculus. This is going to stick around for a while, so you definitely need to know your special right triangles. Starting with our first one, our first special right triangle is going to be a 45, 45, 90. Our second one is going to be a 30, 60, 90. So when we have a 45, 45, 90, here are our three sides. I always call them like the general form. If it's a 45, 45, 90, it's an isosceles right triangle. These two sides are going to be the same. Over here, it's going to be x root 2. Every single time it's going to work out that way. To give an example, let's say we have a right triangle that is, this is 3 and this is 3. If you know those are both 3, you know it's a 45, 45, 90 because it's an isosceles right triangle. Go ahead and use Pythagorean theorem to figure that out. So we're going to do 3 squared plus 3 squared equals hypotenuse squared, 9 plus 9. Because it's a 45, 45, 90, you have 18. Square root of 18 is going to be 9 times 2. Because you have the two 9s, that's going to happen every single time. And you end up with 3 root 2. So right here, our C is equal to 3 root 2 every single time. You don't have to work it out ever again. If you know that's 3 and that's 3, that's automatically going to be a 3 root 2. You can always work it out if you prefer, but every single time it's going to work out that way. So here we have another one. Let's say we have find the hypotenuse of a right triangle if the legs are both 5. So notice, it doesn't even have to tell me that it's a 45, 45, 90. If I know both legs are 5, I know the angles are 45. 5 squared and 5 squared is 25 plus 25. Equals c squared. Well, that's 50. The square root of 50, well, there's a perfect square factor of 25. We're going to end up with 5 root 2. Every single time, no matter what. Okay, so again, you don't have to continue to work that out. If you know it's a 45, 45, 90, you can just put that in. So here, find the value of x. Well, this time, we kind of go backwards. I prefer to set up my general form every single time. Well, this is x, and out of the sides of my 45, 45, 90 are going to be x. My hypotenuse is going to be x root 2. So what I do is I put x root 2 on my 45, 45, 90, and I look at where is there an equation. Wherever there's an equation and I have a number, that's where I start. Since I have x root 2 equals 12, I now want to solve this. To get the x by itself, I'm going to have to divide by root 2. Can't have a radical in the denominator, we have to rationalize the denominator. Multiply by root 2 over root 2. So I end up with, over here I get x equals 12 root 2 over root 2 times root 2 is 2. Well, that can simplify, so I actually end up with x equals 6 root 2. No. So other things that you could do for this, I like to set up the general form every time where my equation is, I solve that equation. You can remember that if we're here, if this is x, you're going to multiply by root 2 to get the hypotenuse. And if you're out here, you're going to divide by root 2 to get one of the legs. So here we divided by root 2 to get the legs. Here we multiplied by root 2 to get the hypotenuse. Every time that's going to be your rule, or you can set up the general form and work it out. Our second special right triangle is going to be our 30, 60, 90. So our 30, 60, 90 here, the hypotenuse is twice as long as the shorter leg. So wherever the shorter leg is, because it's a 30, 60, 90, across from the 30 is always going to be your shorter leg. That's your x. The longer leg is root 3 times as long as that. So I multiply by root 3 to get the longer leg, or I multiply by 2 to get the hypotenuse. Now, if I have the hypotenuse, I'm going to divide by 2 to go this way. And then again, once I'm here, I go here. If I have the longer leg, I'm going to divide by root 3 to get the shorter leg. If you don't have the shorter leg, that's the first thing you want to solve for. So every single time you want to find the shorter leg first. Okay, so if you don't have, you want to start with the shorter leg if you have it. If you don't have it, that's what you find first. So if you have this, you go find the shorter leg, then you do the hypotenuse. If you have the hypotenuse, you find the shorter leg, then you do the longer leg. But those are our rules. I, again, like to prefer to just set up the general form. I remember that it's x, 2x, and x root 3. This is another thing that I don't personally like. They tend to write it as root 2 times x. I always write x root 2. I like the root in the back. And then down here, they have root 3 times x. I prefer x root 3. That way you don't accidentally think something's underneath that radical when it's not. So, going on, go to this one. Can you find the value of f and g? Well, we have 18. Is 18 my shorter or my longer leg? And it's my longer leg. So again, if I'm going to go from 18 to f, I'm going to divide by root 3. If you don't have it memorized to do that, I prefer to set up the general form. So I'm going to say, well, f is x. Over here we have 2x. Here we have x root 3. And then again, wherever I have an equation I can start with, I can't start here because I have two variables. Here I have an equation where I can start. So I'm going to divide both sides by root 3. Rationalize my denominator. I end up with 18 root 3. Root 3 times root 3 is 3. That's going to divide. I'm actually going to end up right here with a 6 root 3. That's my answer for x. So I already know x root 3 is 18, so x is now 6 root 3. Now to get from here to here, I'm going to multiply by 2. So f is 6 root 3. And now if I multiply by 2, I can always say something like x equals 6 root 3. So if I multiply by 2, I end up with 2x equals 12 root 3. 2x is my hypotenuse in this case, so I have 12 root 3. These are some of my favorites. I like these. You just have to remember what the setup is and what you have to do to get to the other point. What do you have to do to get to the leg, the shorter leg, or the hypotenuse, and do those steps. Pause, rewind this, go back over this if you need to watch the video again. Here we're going to do some examples. I have a ramp is used to unload trucks. How high is the end of a 50-foot ramp when it is tipped at a 30-degree angle? So basically we have a ramp is used to unload trucks. So a truck comes up, we unload the ramp. It is a 30-degree angle here, and the ramp is 50 feet. A ramp is used on the trucks. How high is the end of the ramp? I want to know this value x right here. So again, hopefully we remember that if we have the hypotenuse and we want to go to x, every single time the hypotenuse go to x, I'm going to divide by 2. I like to set up the form x. My longer leg is x root 3, and my hypotenuse is 2x. So if I know I have 2x equals 50, I know x is going to be 25 feet. There we go. And then definitely not drawn to scale in this case, but a roof of a doghouse is shaped like an equilateral triangle. So I'm not going to draw the whole doghouse. I'm just going to draw kind of an equilateral triangle, meaning all the sides are the same. The height is 3 feet. So right here, the height of the roof, going straight down, this is 3. Estimate the area of the cross section of the roof. So the roof covers the whole roof. You just want one cross section, so you want the area of one triangle of the roof. So if this is an equilateral triangle, all the angles are 60. What happened to this angle right here? It got cut in half. This is a 30, 60, 90. So if this is a 30, 60, 90, my general form is going to tell me, again, pause and do this on your own. Down here I'm going to have x. My hypotenuse would be 2x. My longer leg is going to be x root 3. I always start wherever I have an equation. My equation is x root 3 equals 3. And starting here, I need to divide both sides by root 3. Rationalize the denominator. I end up with x equals 3 root 3. Root 3 times root 3 is 9. Square root of 9 is 3. Those 3's are going to divide. Remember, the 3's that are outside the radical, not the one inside. The 3's outside will divide out, giving me a value of root 3. So I know that this is root 3 and this is root 3. Multiply by 2. My side right here is going to become 2 root 3. That's not what the question asks, but I was able to figure out all the sides of the triangle. Because if this is root 3 and this is root 3, add them together, it's 2 root 3. Multiply, either way it's going to work. I want to find the area of the triangle. Well, area of a triangle, the formula is going to be 1/2 base times height. 1/2 the base times the height. Well, the base is root 3 and root 3. It's going to be 2 root 3 times the height, which is 3. Really nice here because the 1/2 and the 2 will divide. I have 3 times root 3. Its area, my units are feet, so it's going to be feet squared. There we go. I'm going to pause and go to the next page. I'll be right back. So here we have a bunch of practice problems that we're going to do. I'm not going to do all of them. I'm probably going to save some of them for our class time next week. But what I want you to do before you even start, so don't look back at the page before, can you draw both your special right triangles at the top? Okay, I'm going to be able to draw both of them from memorization. Do you have them memorized? I'm going to draw one that looks like a 45, 45, 90. And then a 36. I always draw my 30, 60, 90s like this. I know on the other page they didn't have it set up this way. I think the 30 was on the bottom. I like my 30, 60, 90 where my shortest leg is on the bottom. This is how I usually draw it. So go ahead, can you fill those in? Remember at the 45, 45, 90, isosceles means these two are the same, multiplied by root 2. Now over here, our shortest side that we start with here is going to be x. The hypotenuse, because it's the 30, 60, 90, is going to be double that. So it's going to be 2x. And we're only going to have 1, 2 in the problem. So over here we're going to have our 3, our x root 3. There we go. So you want to make sure you have those memorized and you can create them if you needed to. Anytime they show up in a problem, I usually will write this down as like my own cheat sheet, basically. I'm going to write it down to quiz myself that I know I have it, and then I'll go solve the problems. Now before I start, I would go through and I would label my general form on every triangle. But what I'm going to suggest you do first is highlight the side that you know. That's going to be where your equation is, and you're going to be working from that side to get your answers. So I'm going to set up an equation here. I'm going to set up an equation here, here, and here. I'm going to set up an equation here, 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 and here. So that's where my equations are going to be set up. I'm going to go ahead and pause for a minute. You should pause and see if you can answer any of these on your own. What's really nice is that 6 is pretty much set up straightforward for us. It matches the general form, and there's not a lot of work we have to do. If x root 3 is equal to 5 root 3, divide by root 3 here. It's just going to cancel. So my x over here is going to be 5, multiply by 2, and I'm going to get 10 right here. So A is 5, and C is 10. Now this matches my general form. If 2x is equal to 72, that's really nice because I just have to divide by 2. Divide by 2, and I get 36. Now from here to here, I have to multiply by root 3. What's really tricky with this one I don't really like is that we solve for E first, but the first blank is D. It's really common to make a mistake there. So remember, E was 36 down here, multiply by root 3 to get 36 root 3. This one I start with x equals 5, and 45, 45, 90s, they have to be the same, so F is also going to be 5. 5 times root 2, going to be 5 root 2. Here, and again, it matches the general form. If 7 root 2 is equal to x root 2, if I divide both sides by 2, I'm going to get 7, and this have to be the same. So we're good. These ones are going to take a little bit more work, so go ahead and test yourself and see if you can do them. Divide both sides here by root 3. Rationalize the denominator. I'm going to end up dividing by 3, and I'll get 5 root 3. So A here is going to be 5 root 3. Multiply by 2. 5 times 2, and again, you only multiply the constant number, not the what's underneath the radical. And end up with 10 root 3. Here, divide both sides by 2. You only divide the 8, you only divide the constant number, not underneath the radical. So I'm going to end up with, and again, E is going to be 4 root 6. Now, when I multiply that by root 3, this takes a little bit more work. So if x, right here, is equal to 4 root 6, and I'm going to multiply both sides here by root 3, I end up with 4 square root of 18. Well, this is hard because tricky because 18 has a perfect square factor. So we have 4, 18 is going to be root 9 times root 2. Square root of 9 is 3. 3 times 4 is going to give me 12 root 2. So again, you have to simplify all the way. X equals root 14 here, which means F is going to equal root 14. So again, I like those ones. Now I have to multiply root 14 times 2. So if x equals root 14, I'm going to multiply both sides here by root 2. I end up with x root 2 equals square root of 28, which has a perfect square factor of 4 times 7. I'm going to get 2 root 7. Now here we have 8 root 6 equals x root 2. Divide both sides by root 2. Now what's nice is because you have the root 6, you can divide those numbers. 6 divided by 2, I end up with 8 root 3. Those are going to be the same. K and M will be the same. I'm going to pause. I believe I'm going to hold off on 8 right now. I am going to come back and do R1 in just a moment, but I'm going to pause for a moment. Okay, so this one's a review down here. You can memorize the rules for the proportions when you do an altitude and create similar right triangles, or I set up this chart every time. I remember the rules for a short amount of time, but then I'm going to forget them in 6 months or a year. So I prefer to know that I could create the chart. Again, it's personal preference. It's up to you. The easiest one to remember, I think, is when it is the altitude here. That B is going to be the geometric mean between the two sides it creates. So if you remember that. I'm going to pause. I'm going to go ahead and create the rest of my chart real quick. So if you want to do that piece, you can as well, but I'm going to pause and create it, and then I'll be back to show you. If you created something similar to this, if you use the same x's and y's, notice that I have the 4 over b over 20 is set up for me in my chart. So if I don't have it memorized the rule, I can use that chart. Again, pause and work them out on your own. I'm going to go ahead and work them out here. For A right here, I see A and I see A here. So the rectangle that forms is the one I need to look at. I'm going to use A over 24 and 4 over A. Again, that is the leg, the piece that's closest to it, and the entire hypotenuse. So that's your rule if you have that memorized. Cross multiply, I have 8 squared, or A squared, equals 4. 24 is actually 4 times 6. So I'm going to write it like that. If I square root this, 4 times 4 is 16. Square root of 16 is 4. Root 6. Here I'm going to multiply. I end up with b squared equals 4 times 20. And 20 can be written as 4 times 5. So when I square root this, 4 and 4 is 16. Square root of 16 is 4. Root 5. You get 4 root 5 here. The last one, C. Again, C is the leg that it is. The piece of the hypotenuse closest to it, and the entire hypotenuse 24. And you can see C's are here. C and 24, C and 20. And again, it doesn't matter if the C's are here or here. Geometric mean technically has to go here. You're going to have the same proportion. So I'm going to cross multiply, I get C squared. Now 24 is 4 times 5. Sorry, 20 is 4 times 5. 24 is 4 times 6. Square root these. 4 and 4 is 16. Square root of 16 is 4. 5 times 6 is 30. That's underneath the radical. And does 30 have any factors that are perfect squares? 2, 15, 3, and 10? No. So I am done. That's my final answer. And there we go. So again, remind us to do this in class. I'm going to try to put it on a Pear Deck slide or something like that if I remember right now and I go do that. Otherwise, have a fabulous week. Have a fabulous day. See you next time.